All right, ladies and gentlemen, this is the study guide for Unit 5, Advanced Algebra through Data Exploration. This is the first half of this unit, sections 5.1 through 5.5. Section 5.1 is matching a graph with the situation. All right, so here we go. So the first problem, we have a kettle of boiling water cools in a warm kitchen. X is the time that has elapsed in minutes. Y is the temperature of the kettle in degrees Celsius. I'm going to extend this, and I'm going to also do it in Fahrenheit. Okay, so I'm going to show both of those. All right, so think about this. As the time goes on, the temperature will cool down. So the graph that matches that would be graph B. All right, well, there's only one graph for number 2. A piece of paper is folded in half. It is then folded in half again and again. X is the number of folds. Y is the thickness of the paper. So as you fold the paper, it's going to get thicker and thicker, so that graph has to be going up like graph A. All right, now I'm going to actually go in and I'm going to label my X and Y axis for both of these. So again, on this first graph with the boiling water, X is the time, and Y, in this case, is the degrees. Now I'm going to do that in both Fahrenheit and Celsius when we get down to the bottom. Okay, for graph A, it's the number of folds. And then it's the thickness. Again, as you fold the paper, it gets thicker and thicker, so the line is going up. Graph B, as time goes on, the temperature goes down. All right, so what we're going to do in number 3 and 4 is we're going to give a reasonable domain and range value. So number 3 is going to go with the boiling water and the time, all right, or the cooling kettle over time. So the domain, remember, is your X. So X is in the middle. The range, remember, is your Y, and Y is in the middle. So we're going to come up with some reasonable domain and range values. Okay, now this one we talked a bit about in class. So time, obviously, when you take it off the stove, that's at time 0. It starts cooling immediately after you take it off the stove. And then it cools down to like room temperature. Okay, so about how much time is that? Well, it's maybe about 30 minutes before it cools down, maybe even a little bit longer. So a reasonable domain would be 0 minutes to 30 minutes. The range, again, depending upon if you're talking about Celsius or Fahrenheit, I'm going to do both. So first I'm going to do this in Celsius. Water boils at 100 degrees Celsius. And room temperature is about 24 degrees Celsius. Okay, so my range value would then be from 24 degrees to 100 degrees Celsius. If we're talking about Fahrenheit, okay, Fahrenheit boiling water is about 212 degrees Fahrenheit. Room temperature we talked about in class would be about 72 degrees Fahrenheit. So if you used Fahrenheit, you would say 72 degrees to 212 degrees. Okay, so either one of those is fine. Okay, the next one, this is for folding the piece of paper. So again, X for the domain is in the middle. and the range y is in the middle. So number of folds. I don't know if you've ever tried it, but you can only fold a piece of paper so many times. Okay? The best I could do was 6 folds. So 0 to 6. Okay? I could only fold it in half 6 times, and then I couldn't fold it anymore. Now, the thickness. Okay, well, you could say the thickness of the paper is 0, but technically there is a thickness to a piece of paper. I mean, it's really, 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 really thin. So technically, the thickness of a piece of paper is 0.0039 inches. Okay, if you did not know that, now you do. All right, and when you fold it in half and fold it in half and fold it in half, when you get to about 6 folds, it's only about a ½ inch thick. Okay, try it sometime. See how many times you can fold it, and then look about how thick that is. It's only about a ½ inch thick. All right, moving on. Section 5.2. Find the explicit equation of the associated continuous function using f of x notation for problems 3 and 4. All right, so we have a pattern here in our graph. We notice that it is a straight line pattern. That immediately tells us, remember, it is arithmetic. Let's put the numbers in. So we see 1's partner is 8, 2's partner is 6, 3's partner is 4, 4's partner is 2. And arithmetic means we are adding. So here we are adding a -2. We are adding a -2, so it's going down 2 each time. Remember to go backwards. We need to know what's under the 0, and if we go backwards, that would be a 10. Okay, now we're going to write the equation for this. So first of all, the pattern is going down 2, so we say -2. Followed by the letter x plus 10. There is our function. Again, that one is arithmetic. The next one, we see that it is a curved pattern. Curved pattern tells us that it is geometric. And we are multiplying. All right, so I'm going to put my numbers in. So 1's partner is 9, 2's partner is 5.4, 3's partner is 3.24, and so on. Now, I got to figure out what I'm multiplying by. Just by looking at it, I do not know. So I am going to take the 5.4 and divide it by 9. Again, pick a number and divide it by the number behind it. So here we go. So I'm going to go 5.4. And I'm going to divide it by 9, and it tells me I am multiplying by 0.6. So I am multiplying by 0.6. And if you want to verify that, go ahead and multiply 5.4 by 0.6. You should get 3.24. Okay, going backwards. Again, instead of dividing, instead of multiplying, I am going to divide. So I'm going to take the 9, and I'm going to divide it by the 0.6. And I see that the number under the 0 is a 15. Now, since this one is geometric, remember we use parentheses. The 15 goes in front of the parentheses, and the 0.6 goes inside, and then don't forget the x is an exponent. Again, geometric, we are multiplying, and x needs to be the exponent. All right, moving on. So we are given a function, f of x equals 4x minus 6. We want to find x if f of x is 30. Okay, be very careful. Don't mess up on this. So we're going to put the 30 in for f of x. And now we're going to solve for x. So add 6. So now 36 equals 4x. Divide by 4. And we find out that x equals 9. All right. Same thing with the next one, except it says g of x, but we don't do anything different. We do it the same way. We're going to replace the g of x with negative 22. Set that equal to the 2x plus 4. Solve. So take away 4. So negative 26 equals 2x. Divide by 2, and we find out that x equals negative 13. Again, at any time, if you need to pause this because I'm going too fast, just pause it, rewind, whatever you need to do. All right, that was chapter 5.2, or section 5.2. The next one is section 5.3. All right, we're going to do a little bit of graphing. So we're going to graph this. Okay, remember this is our y-intercept. That is where we start. And then the slope tells us where to go. So we're going to start at 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. So start up 7. The slope has a negative in front, so that means down. So we're going to go down 2. And remember, we always go to the right. So down 2, right 3. 1, 2, 3. Down 2, right 3. Down 2, right 3. Okay, and you can go backwards and put another dot if you want. And connect the dots with a straight line. Voila. All right, so there's y equals negative 2/3 x plus 7. Remember, negative, the line should be going down. All right, moving on. So again, here's our y-intercept. And here is our slope. All right, starting at negative 7, so down 7. 1, 2, 3, 4, 5, 6, 7. And our slope is positive, so that means we're going to go up and then right 3. So up 3, right 4. Okay, I think I said that wrong. Up 3, right 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And I can go backwards one more. 1, 2, 3, 1, 2, 3, 4. Okay, that's all that will fit. Draw your line through the dots. Voila. There we go. Okay, you've been doing graphing for quite a while now. That should be very routine. All right, number 11. We're going to solve, without solving for y, we are going to find the x and y intercept. All right, so remember, the x-intercept, the y value is always 0. In the y-intercept, the x value is always 0. All right, so if we plug the 0 into y, that's basically gone. So we are left with 3x equals 12. Divide by 3, and we see that the x-intercept is 4. Okay, now over here, the y-intercept, we take the 0, we plug it into x. Again, that disappears because anything times 0, it's 0, it's gone. And we are left with negative 4y equals 12. Divide by negative 4, and we see that the y-intercept is negative 3. Okay, let's do that one more time with number 12. So again, I'm going to go ahead and do my x-intercept. The y value is 0. The y-intercept, the x value is 0. I'm going to plug the 0 into y. That's going to disappear, so I'm left with negative 2x equals negative 18. Divide by negative 2, and I see that x is 9. Plug the 0 into x. That disappears, so I see 6y equals negative 18. Divide by 6, and y equals negative 3. Okay, moving on to the next page. Just had a mastery quiz on this last week, so you hopefully are really good at this. We are going to use the point-slope formula to find the equation of the line y equals mx plus b form when given 2 points. Remember, it's going to take 4 steps. Step 1, we need to find our slope. So remember, slope is y2 minus y1 over x2 minus x1. Let's plug the numbers in. So that would be 4 minus negative 10 over 5 minus negative 2. You need to look to see if there's a sign change, and there is. There's a sign change on top and the bottom. So minus a negative becomes plus, and the minus a negative becomes a plus. So the numerator is 14, the denominator is 7. And that simplifies to just plain old 2. Okay, step 1 is done. Step 2 is plugging it in. So remember, we are going to replace the y1, we are going to replace the slope, and we're going to replace the x1. We do not do anything with the y or the x. They need to stay. All right, so we're going to plug them in. Here we go. So y minus, I'm going to put the negative 10 equals the slope I just found, which is 2, times x minus the x1 value is negative 2. All right, before I move on to step 3, I need to go ahead and do sign changes. Again, there are 2 of them. Minus a negative becomes plus. Minus a negative becomes a plus. Step 3, distribute. So now we have y plus 10 equals 2x plus 4. And the last step, subtract 10. And so our answer in slope-intercept form is y equals 2x minus 6. Okay, let's do this one more time. So first we're going to go ahead and do the slope. So that would be negative 5 minus 13 and 3 minus negative 3. There is only one sign change, and that's on the denominator. The minus a negative becomes plus. The top does not change. All right, subtract. Negative 5 take away 13. That should be negative 18. 3 plus 3 is 6. Simplify that, and I believe we get negative 3. So the slope is negative 3. Step 2, plug the numbers in. Again, we're going to replace the y1. We're going to replace the slope. We're going to replace x1. So y minus 13 equals the slope, which is negative 3, times x minus the negative 3. Again, there's only one sign change. Change that to x plus 3. Step 3, distribute. So now y minus 13 equals negative 3x minus 9. Negative 3 times 3 is a negative, so I'm going to put a minus 9 there. And finally, the fourth step, add 13. So our final answer is y equals negative 3x minus 6. Whoops, hold on here. Hold on. My mistake. I didn't put 13 here. That's 13. There we go. Negative 9 plus 13, my apologies. Negative 9 plus 13 is plus 4. Okay, be careful so you don't go too fast like I just did and screw up. All right. Number 15, write the equation that is parallel and 6 units down from the function. Well, first of all, parallel tells me it's the same slope. So I can write y equals 4x. Okay, now the next part says 6 units down. Down means subtract. So I am going to subtract 6 from the 10 and I get 4. So that means my y-intercept is plus 4. If it said up, then we would add. Okay, the next one. Again, it's parallel. Oh, I've got it right here, up. Okay, it's parallel. Okay, that tells me again that's the same. So y equals 2x. And it's 3 units up, meaning I'm going to add 3. So my y-intercept is minus 5 or plus negative 5. Okay, think about that carefully. Moving on. Write the equation that is perpendicular to the function at its y-intercept. Okay, so perpendicular tells me to change sign and flip. So that means my slope is now positive 2/5 followed by x. And then it says at its y-intercept, so that's going to stay the same. It's just going to stay plus 5 because it's the same y-intercept. Number 18, again it says perpendicular, so that means we are going to change sign and flip. So that would be negative 3 over 1, but remember we do not need to put it over 1, so negative 3x. Again, it's at the same y-intercept, so plus 9. All right, moving on. Section 5.4. Fill in the table below, plot the points on the graph, and draw a line through the points. Answer the questions that follow. All right, so this is where we need our calculator. So the first thing we're going to do is we're going to go to our y equals, clear out anything that's in there, and type this equation. So it says x squared minus 6x plus 5. Okay, we cannot type in equals 0. Never type in equals 0. We're going to go to the table. And we're going to line the table up with the table on our paper. So that means we want the 0 at the top. There we go. The 0 is at the top. Now we can fill in the rest of it. All right, so 0 partner is 5. 1's partner is 0. 2's partner is negative 3. 3's partner is negative 4. 4's partner is negative 3. 5's partner is 0, and 6's partner is 5. Okay, now we're going to graph it. So over 0 up 5. Over 1 up 0. Over 2 down 3. Over 3 down 4. Again, if I'm going way too fast, you just have to pause. Okay, 4 negative 3. 5 0. Whoops. Fix that. 5 0. And 6 5. Don't forget to draw the line through the dots. If you forget to do that on the test, I will take a point away. All right, so now it says, what is the y-intercept? Okay, well, the y-intercept is right there. And that would be also right there on our table. So the y-intercept is 0, 5. Does this graph have a minimum or maximum point? Well, it is a minimum. What is that minimum or maximum point? Okay, which is also known as the vertex. Okay, well, you can see that that is also right here. So it's 3, -4. Okay, what are the x-intercepts? Okay, well, the x-intercepts are here and here. And you can see right here and here in the table. So the x-intercepts are 1, 0, 5, 0. All right, let's go to the next one. Let's do the same thing. So we're going to go to our calculator. We're going to go to our y equals, clear that out. Let's type in x squared plus 2x minus 8. Go to the table. Okay, now you need to line the table up with the table on your paper. There we go, -4 is at the top. Let's fill in the table on our paper. So -4, 0, -3, -5, -2, -8, -1, -9, 0, -8, 1, -5, 2, 0. Okay, plot your dots. Again, pause it if I'm going too fast. Okay, what is the y-intercept? Zero, -8. Minimum or maximum? Okay, minimum. What are the x-intercepts? That would be -4, 0, and 2, 0. Okay, moving on. All right, we're going to solve. So the last section was solving equations. So we're going to solve this equation. All right, here we go. So first step. Step 2. Whoops, hold on here. Made another mistake. 53 take away 5 is 48. Sorry about that. Again, 53 take away 5 is 48. Don't be in such a rush, Mr. Ellering. All right, divide by 3. And 48 divided by 3 is 16. All right, now this is what this was the main focus of this lesson. Okay, to get rid of a square, we have to take the square root. And remember, when we do the square root, there are going to be two answers because it's quadratic. So we're going to put a plus and minus in front. Now, 16 is a perfect square, and the square root of 16 is 4. So the two answers to number 21 are plus 4 and -4. All right, moving on, number 22. Step 1. Step 2. Okay, the last step, square root. Again, don't forget the plus and minus. So 25 is a perfect square, so our final answer is x equals positive or negative 5. Okay, 23. Step 1. Step 2. (144) divided by 4 is 36. Last step. So x is plus or minus, positive or negative 6. Okay, 24, I'm just going to go ahead and solve it without talking. All right, now the cumulative review section. Again, this is 20% of your grade. So the first part, we're going to do a little bit of solving. All right, here we go. We'll notice that there is a variable on both sides, and I like to keep my variable positive. So my first step is going to be, and there's more than one right way to do this, folks. This is the way I do it. I'm going to keep my x positive, so that means I'm going to subtract 3x. Now I have to add 8. And then I divide by 2, and I have my answer. Okay, now on letter B, first you need to okay, so these two we need to combine first. Okay, they have to be on the same side of the equal sign. Same side, don't cross yet. We're just combining like terms on each side. So these two get combined, and this is what we have. And then on this side, these two get combined, so we have now it's just like letter A, we're going to solve it. So here we go. Again, I'd like to keep x positive, so I am going to do this first. Okay, now I have to subtract 6. And then my last step, I have to divide by 3. Okay, so 2 more problems just like that. Okay, I'm going to solve these without talking. All right, last part, add or subtract the polynomials. All we're doing here, ladies and gentlemen, is combining like terms. You will notice in letter A, there is a plus sign in the middle, and in letter B, there is a minus sign between the grouping symbols. Okay, so in letter A, nothing to worry about. All we have to do is combine our like terms. However, in letter B, because of that minus sign, we need to rewrite it before we can combine like terms. All right, so let's start with letter A. So we're going to combine like terms, and I'm going to color code as I do this. So those two get put together. That would be negative 2a squared. Okay, combining the a's, that would give us and finally, okay, and then that's our answer. It's an expression. You cannot solve it. You just stop by combining like terms. Okay, now letter B, because of that minus sign, we have to rewrite this. So the first part does not change. 5x squared minus 2. Now, when there's a minus sign in front, you need to distribute that minus sign through. So we're actually going to, it's like multiplying by negative 1. So what's going to happen is the signs are all going to change to their opposite. Again, only when there's a minus sign in front of that grouping symbol like that. So I'm going to rewrite this as negative 8x cubed minus 2x squared. That becomes plus x, and then that becomes minus 9. Now, when we do combining like terms, we're going to start with the biggest exponent. We notice that there's a big exponent right here, negative 8x cubed. There is no other x cubed, so there's nothing to combine with it. So when we write our answer, we should start with that one. Okay, now 5x squared and minus 2x squared can be put together. That becomes, okay, next we should do the x variable. Okay, you'll notice there's an x right here. It does not have a partner, so it's just going to be plus x. And then the minus 2 and the minus 9 get put together. That becomes minus 11. That's our answer. All right, let's wrap this up. Again, in this problem, there's a plus sign in the middle. Nothing special to do, just combine your like terms. And that is your answer to that one. Again, over here, we've got this minus sign here, so we're going to have to rewrite the problem and change those signs. The first one does not change, but the second one does. Again, notice how the signs all changed to their opposites. Okay, now this one, again, we're going to start with the x cubed. Now there are 2x cubed, so we're going to combine those. I notice that there is only one x squared, so that one just gets written there. I also notice that there is only one x, so, and then last, the minus 6 and the minus 10. And there is our answer, combining like terms. All right, that is the end of the study guide. Good luck, folks. See you later.